How deepfakes work. You watch a video of someone speaking. Their face looks right. Their voice sounds right. Everything lines up, except they never actually said those words. That is the idea behind deepfakes. They are not edited in the traditional sense. They are generated, built by systems that learn how people look and move, then recreate it. So today we are going to walk through how deepfakes actually work and how a computer can create something that feels surprisingly real. Chapter 1. What a deepfake is. A deepfake is media that has been synthetically generated or altered using AI. This can include video, images, or audio. The goal is to make it appear as though someone said or did something they did not. The term comes from deep learning and fake. Chapter 2. The role of data. Deepfakes rely on large amounts of training data. This typically includes images or videos of a person from different angles and expressions. The more data available, the more accurate the result can be. The system learns patterns from this data rather than memorizing specific frames. Chapter 3. Neural networks. At the core of deepfakes are neural networks. These are models designed to recognize patterns in data. They can learn how faces look, how they move, and how expressions change over time. This allows the system to generate new content that follows similar patterns. Chapter 4. Generative models. Deepfakes often use a type of system called a generative model. One common approach involves two networks working together. One generates content. The other evaluates it. The generator tries to create realistic output, while the evaluator checks how convincing it is. Over time, the generator improves. Chapter 5. Face mapping. For video deepfakes, the system maps one face onto another. It identifies key features such as eyes, nose, and mouth. It then aligns these features with the target video. This allows the generated face to move in sync with the original footage. Chapter 6. Expression and motion. It is not just about replacing a face. The system also needs to match expressions and motion. This includes blinking, speaking, and subtle facial movements. The model learns how these changes occur and applies them to the generated face. This is what makes the result appear natural. Chapter 7. Voice synthesis. Deepfakes are not limited to visuals. They can also involve audio. Voice synthesis models learn how a person sounds based on recordings. They can then generate new speech that matches that voice. This allows both video and audio to be combined into a convincing result. Chapter 8. Limitations and artifacts. Despite improvements, deepfakes are not perfect. There may be small inconsistencies in lighting, movement, or timing. These artifacts can sometimes reveal that the content is not real. Detecting these details is part of identifying deepfakes. Chapter 9. Uses and concerns. Deepfake technology has both positive and negative uses. It can be used in entertainment, education, and visual effects. However, it also raises concerns about misinformation and misuse. Understanding how it works helps people interpret what they see more carefully. To wrap up, deepfakes are created using AI systems that learn patterns from large data sets. Neural networks generate new content that mimics real people's faces and voices. Techniques such as face mapping and voice synthesis combine to create realistic media. While the technology can produce convincing results, it is not without limitations. As it continues to develop, understanding how deepfakes work becomes increasingly important. This has been a mini Leviathan production. If you enjoyed it, check out our other videos. See you in the next one.